Bit of practice, okay? Easy peasy. If you cannot see things on the board, I will tell you. So we have two bakeries, okay? Let's say we have two bakeries, different resources here. So the production possibilities frontier looks outward like a bow. One type of resources here, so production possibilities frontier is is a straight line. And the question is, let's say we have pizza on the vertical axis and cakes on the horizontal axis. Okay, so for the upper chart we have 0, 10, 20, 30 for pizzas, and for the cake we have 30, 45, 50. Right? On the bottom chart we have 0, 10, 20, 30 for pizzas, and for cakes we have 15, 30, 45. Straight line. We have two questions for each of the charts, a bit of practice. Let's try to answer those questions. It's not going to take long, I guess, so if you are ready to shout out the numbers. If you don't see the question, let me read it out. The first question for the upper chart is, how much is the opportunity cost of pizza when we increase the number of pizzas produced from 10 to 20? So how much is the opportunity cost of pizza per pizza when we increase the production from 10 to 20? How much is that? How much would that be? Let's think about the question again. So I have arrow here to increase the production. So let's say originally we were making 10 pizzas. Now we make 20. We have extra pizzas, right? That must cost us something because I had to spend time making extra pizza, right? It must have cost me something in cakes. Okay? So I used to be at this point, 10:45. Now I must have moved to this point, 20:30. Right? So I got more pizzas. The question is, how much is the opportunity cost of pizza? Per pizza. Not of all 10 pizzas, but per pizza. Okay. How much is it? Just tell us if you already got the answer.
I can't really see the number on the graph.
Right, okay. So this is 30, this is 45. This is 30, this is 45. So you got 10 pizzas, but you lost 15 cakes, right? Yeah, please.
And so it's 2 or 3 cakes?
Yeah, 3 seconds. Not 2/3, but 3 seconds. 1.5, right?
Yes.
Yeah, 3 seconds. So, let me explain the answer so everybody's on the same page, right? Previously, we had 10 pizzas and 45 cakes, right? Previously, if we had 10 pizzas before, we must have been on this level. At that level, we also have 45 cakes, right? Next, as we move to the next level, 20 pizzas, I must have less cakes. So I have 15 less cakes because I moved down from 45 to 30 on the cakes axis. So I lose 15 cakes for 10 pizzas. It's like I buy 10 pizzas for the price of $15. How much is each pizza? $1.50, right? So the opportunity cost of pizza is 1.5 cake. Or 3 seconds, you're absolutely right.
So which parameter should we use?
This divided by this. Right.
No, I understand. So the opportunity cost is what I lost in cakes and what I lost in time. What I gained in time. Sorry. This is the time plus the cakes. That's the opportunity cost.
That's a very good question, yes. So, what do we include in the opportunity costs? Because we try to use our time efficiently, the cakes already take account of the time, right? Right? So, when you go hiking for 3 hours, right? What else could we have done with the 3 hours? You could have either watched a movie or sat on a bench, right? Let's say you prefer watching a movie to sitting on a bench. So the opportunity cost of hiking is watching a movie, right? In that example, we don't say that opportunity cost of hiking is 3 hours plus watching a movie, right? Because watching a movie already takes account of the time. So that's why here we don't add the time here. Oh, we don't have to, because cakes already take account of the time, right?
Yes.
So if I get more pizza, I lose cakes. Where's the time? Well, the cakes that I lose already take account of the time, right?
How much are the cakes? I'm sorry.
So, maybe the numbers are not visible. This is 30, this is 45. This is 10, this is 20. If I had 10 pizzas originally, I must have had 45 cakes, right? So 10 pizzas, 45 cakes. If I move up to 20 pizzas, I only have 30 cakes. So I came down from 45 to 30, I lost 15 cakes, but I gained 10 pizzas.
So the opportunity cost is 50 cakes.
Of 10 pizzas,
Of
but
10
per
pizzas.
pizza is going to be 1.5 cakes. So, to answer this, right, 1.5 cakes per pizza. Let's have a look at the opposite question. Yes, do you have a question? You already got the answer here. Let me explain the question first. So, to make sure everybody's on the same page, let's have a look at a different question now. When I increase my number of cakes produced, from 45 to 50, when I increase my number of cakes produced from 45 to 50, how much is the opportunity cost of cake per cake? Anyone? Somebody wanted to give me the answer, yes? Is it 10? Did somebody say 10? Yeah, the cost of all 5 cakes is 10 pizzas, yes. But per cake is going to be?
1.
2. 2, right? So, look, what's going to happen is, when I increase my production of cakes from 45 to 50, so from 45 to 50, I get 5 cakes, right? I get 5 cakes. But at 45 cakes, I used to have 10 pizzas. At 50 cakes, I have no pizzas. So I gained 5 cakes, but lost 2 pizzas, right? So it's just like imagine this is dollars, so it's easy to calculate, right? I gained 5 cakes for the price of $10. How much is the price of cake? $2, right? So the opportunity cost of cake is 2 pizzas, yes. Now here in the upper chart, because the slope of the PPF changes, right? Here it's flat, here it's steep, here it's steep, here it's flat, that's the slope, right? Because the slope changes, the answer also changes as I look at different numbers, right? So for example, if I change it from 20 to 30, as I get 10 more cakes here from 20 to 30, right? I'm gonna lose from 20 30 cakes. 30 cakes for the last 10 pizzas, right? So each pizza is going to cost me 3 cakes, right? So the answer changes depending on the range because the slope changes. But for the PPF below, the answer doesn't change when we change the numbers. That's why in this question, I don't need to tell you any numbers because the slope is always the same. It doesn't matter if you go from this point to this point, or from this point to this point, or from this point to this point. The opportunity cost will always be the same. So, how much is the opportunity cost of pizza? How much is the opportunity cost of pizza on the bottom chart?
If you increase your production from 10 pizzas to 20 pizzas.
Exactly, you just take any example and calculate, right?
It's 15 cakes.
Per 10 pizzas.
Per
So
10 pizzas.
Per pizza is?
1.5.
Yes, 1.5, right? So that is 1.5 per pizza, then per cake. Remember, it's always inverse, right? 1.5 is 3 seconds, right? So inverse of that is 2/3, right? 2/3, right? 2/3, right? So if you just take any example, for example, I'm going to go from point A to point B, easiest, right? So from 0 cakes to 45 cakes, I'm going to get 45 cakes, but I'm going to lose all 30 pizzas, right? So 30 over 45 is 2/3, right? It's just like I got 45 cakes for $30, right? How much is the price of cake? 2/3 of a dollar, right? Questions? Next, let's have you guys draw a PPF somewhere on a piece of paper. Let's say we have a bakery. You are making apple pies and banana pies. A and B. It's easy. Apple pie, banana pie. A, B. Okay. And let's say we have 2 people working in the bakery. Let's say John and Mary. Anyway, make it short. You can just have J and M. JM. Less time to write things. John, Mary, JM. And we have apple pies, banana pies. AB. Apple A, banana B. So John per hour can make either, let's say, 10 apple pies or 5 banana pies. Yes. And the Jane can make per hour either, well, let's say 8 apple pies or let's say 5 banana pies. Okay. Or maybe we can make her better at bananas. Sorry about that. Let's change this to 8 and let's change this to 5. Okay. And that's per hour. That's how much they can make per hour. Let's calculate if work day is only, make it simple, say 5 hours. The rest of the day they have to clean the kitchen and everything, right? So let's say work day is 5 hours. Can you please draw your daily PPF for the whole bakery for 2 people, right? So it means there'll be some options, right? Let's say, no, I'm sorry, let me change the numbers. It's going to be probably simpler if we have something that is very difficult to make, like we have for pizza. This will be kind of too tricky. Let's say maybe 2 for 3, and this is, let's say, 3 for 2, something like that. I'm sorry. I'm going to change it. It's still quite tricky. Let's say 1, 3, 1, 2, maybe like this. And let's say we have apple pies here. On the horizontal axis, they are more tricky to make. Why it's easier? Because every time we are just adding 1 more. That's why it's nice for me to have 1 here. It will be easier to calculate things. Okay. So of course, if they have 5-hour day and each can make 1 apple pie, in 5 hours they can only go up to 10, right? Because 2 people making 1 apple pie per hour, at the maximum during 5 hours they can make 10, right? This is going to go up to 10 from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Vertical, how much is going to be? Well, I think 3 times 5 is 15 plus 2 times 5 is 10. Together, if they spend all the time only making banana pies and no apple pies, together this will be 25. Right? So can you guys make up the production possibilities frontier? So I'm going to do it here. If you you want to compare, I guess, but you'd better try yourself. Yeah. Not enough space. That's A for B. Right? So let me start from the top. Doesn't matter where you start. If they only do bananas, banana pies, in 5 hours, I think that guy can make 15. In 5 hours, Mary can make 10. So together, I think it's going to be 25. Then we need one more apple pie. Whom are we going to send to make an apple pie? John or Mary?
Both of them are equally efficient.
No, because during the time of making one apple pie, John can make 3 banana pies. But she, during the time of making one apple pie, she can make only 2 banana pies. He's better in banana pies than her, because he's faster with banana pies, right? So we still need one more apple pie. We need to move over here, right? But if we send her, we're going to lose only 2 banana pies. But if we send him, he's really good at banana pies. He's making them fast, right? We're going to lose 3. So whom am I going to send? We're going to send her, right? Because if she has to make 1 apple pie, she instead loses the chance to make only 2 banana pies. So we're down by 2. If I send him, instead of making 1 banana pie, he would lose the chance to make 3 banana pies. I will go down by 3. If I'm the boss, I direct both of them. I would send Mary to make the apple pie, not John, right? So we're going to go down by 2 to 23, a point here. And actually, if I need a second banana pie, I still going to direct her. Of course, this is per hour and there are 5 hours, right? Right? So I'm going to keep directing her until she spends all of her time only making apple pies, right? So because it's the same person, the same ratio of 1 for 2, 1 for 2, 1 for 2, this line is going to be the same slope, only until she spends all of her time making apple pies, right? If she spends all of her time making apple pies, how many apple pies can she make? 5, because there are 5 hours in a day, and she can make only 1 per hour, right? So this line stretches up until 5 over here, right? So if she's only spending her time making apple pies, how many banana pies are we going to make? It means John spends all his time making banana pies, right? 3 per hour times 5 hours in a day, that's 15, right? So I'm not sure how straight is my line. This should be at the level of 15. It's kind of almost there, right? You understand? So it's going to be going down until 15.5, right? After that, again, it's the same person. There's going to be a straight line again after that, right? Before that, 1 kind of opportunity cost, 1 for 2, and here 1 for 3, right? Because it's a straight line, I can just connect 2 points and continue, or just connect this 10 here, right? I can just connect 2 points because it's a straight line, right? Right? So you can just connect 2 points, but any of these points should actually work. For example, let's take 8. if they make 8 banana pies, it means that she spends all of her time making 5, and he spends all of his time, not all of it, he spends some time making 3, right? So he still has another 2 hours left. How many banana pies will he be able to make in 2 hours? They're going to be 6, right? So this should be at the level of 6, which it kind of is, right? Okay? Whew. So there's a bit of practice for you, yes? Yeah, that's good practice. You practiced with questions. Now you practiced with making your own production possibilities frontier, right? So far, so good. Any questions? While you're discussing, that's okay. If you are helping each other, that's good. I'm just gonna prepare the new topic. For the new topic, I want to have a bow-shaped PPF, so I'm gonna draw that while you're helping each other. So again, that would be, let's say, 15, 14, 12, 9. Okay. Okay, let's turn the screen here. Okay, so a couple of subtopics, and that will be enough for today. Marginal cost. We already talked about marginal costs last week. Marginal, like the margin in your notebooks, I don't see in recent notebooks, but anyway, we used to have margins. That's extra space at the side of the page. Anyway, marginal means additional from English, right? So marginal cost is additional cost of one more unit. We can actually see marginal costs on the PPF. Okay? So, let's make a chart of the marginal cost. Marginal cost of pizza. Let's make a chart of marginal cost of pizza from this PPF. So we have 5 pizzas, 1, 2, 3, 4, 5. The first pizza is going to cost me 1 cake, right? Because if I want to have that first pizza, I'm going to lose 1 cake, right? So let's put 1 here. There's a kind of a, that's the marginal cost of the first pizza, right? Okay, the second pizza is going to cost me 2 cakes, right? So that's the marginal cost, the additional cost of 1 more pizza. That's 2, very easy, like that, right? The third pizza is going to cost me 3 because we'll go down to 9, right? So there's 3 over here. The fourth pizza is going to cost me 4, going down from 9 to 5, right? This is 4. This arrow shows 4, the size of the arrow, right? So the fourth pizza is going to cost me 4 in cakes, right? And the fifth pizza is going to cost me all 5 cakes, right? So what we learned here is that, well, a lot of the concepts are connected in economics, right? Opportunity cost is what we have to give up in order to do something, right? It can be related to a total of 3-hour hiking, or we can also have a look at opportunity cost per pizza. Then it's kind of similar to marginal cost, because marginal cost is the additional cost of additional unit, right? And also, it's kind of all related to PPF, production possibilities frontier, because if I want to have more pizza, I gotta have less cake, because PPF shows all the possibilities that are possible to produce, right? So if I want to have more pizza, I'm going to lose out on cakes. That's also related to opportunity cost and marginal costs. We can derive one from another there, right? So there's marginal cost. Why are we going to use it? Why are we talking about it now? One, because concepts are related, and secondly, because, as I said, we have 2 types of efficiencies. Perhaps this will be the last subtopic for today. 2 types of efficiencies. Productive efficiency, I'm going to give a definition now. Before, I just explained how it looks like on the chart, right? I haven't given a formal definition. Productive efficiency and allocative efficiency. Right? Productive efficiency is the situation when productive efficiency is achieved when we cannot produce more without, I'll use WO for without, okay? Cannot produce more, cannot produce more of one good without giving up some of the other good. Again, it's just a sentence. Perhaps if my English is not so good, I read it, I don't get anything. I'm going to show it to you on the chart. It's going to be really, really easy. Right? So let's have a look at this point over here. This point A. Is it efficient? It's not efficient, right? And it also connects to this sentence. From point A, I can have more of this or this, right? Then I don't have to give up the other one. I can just raise this point A. I can have more cakes without giving up pizza. Or I can move this point to the right. I can have more pizza without giving up cake. But if I look at this point B, is it efficient? It is efficient, right? So I cannot have more pizza without giving up cake. I cannot move directly to the right, straight to the right. I also must go down, right? So I cannot have more pizza. Let's say one good is pizza. I cannot have more pizza without giving up some of the cakes. And vice versa. I cannot have more cakes. I cannot just go up. I need to also move, lean to the right, to the left as I move up. So I cannot have more cake, right, without giving up some pizza. So now it kind of makes sense, right? We're already at the edge of what we can do, so we are already efficient. We're not wasting time, right? So I cannot even do more of anything. If you want me to write more essays, I gotta spend less time on presentations because I'm already working hard. Okay, that's the meaning of productive efficiency. For allocative efficiency, okay, allocative efficiency is achieved when marginal cost equals marginal benefit. Remember we talked about it last week. When you chose how many ice creams to eat, when you chose how many kilos of fertilizers to add to the compost or to the garden or something, right? as long as marginal benefit is greater, you need to have more of that, right? Right? Anyway, we're going to leave it for later, because for now we only discovered marginal cost from here. We haven't discovered marginal benefit from here, right? So we don't have time for that. We're going to leave that for next week. We'll finish with general understanding of allocative efficiency a little bit. We're going to introduce more details of each of these next week. And we have understood productive efficiency a bit better. Questions? Let's go for a break. See you in the computer lab.